Hello everybody and welcome to another tutorial on C programming. In today's session we'll be taking a look at using function calls or more specifically using recursive function calls. What is exactly the meaning of recursion? So if you do not already know this, recursion is the ability of a function to call itself. So when a function calls itself, then the phenomenon is termed as recursion. In normal programs, what we generally do is we call another function from one function. Say there are two functions, the main function and another function called void display. So if I try to call void display from main, that is a normal type of function call. But if the void display function calls itself from inside void display, then that kind of a phenomenon is called as is referred to as recursion. Let us take a look at the list of programs that we have before us. So the first program says that we have to find the factorial of a number by recursion. So if you do not already know what is the factorial, so let us say a number called example factorial. Say we want to find the factorial of 5. So this exclamation mark corresponds to factorial. It is a symbol represents factorial. So the factorial of 5 is 1 multiplied by 2 multiplied by 3 multiplied by 4 and multiplied by 5. So this represents the factorial of 5. So what is the normal technique of finding the factorial of a number? That is by using a non-recursive method. So we have to execute a loop that runs from 1 to 5, and within that loop we will have to keep multiplying a variable whose initial value is 1 with the value of the loop counter. Okay, so that is how we normally calculate the factorial of any given number. But in this program the problem is slightly different. It says that we will have to find the factorial of a number by using recursion. So first of all, let us take a look at the code that we have before us. So here you can see that we have the main function. Within the main function we have all the code, and apart from the main we have the function called fact. So fact returns the factorial of a number, and there is another function called ifact which is used to calculate the iterative value. So if we are to find the factorial using a normal technique, that is not by using recursion, by using a non-recursive method, we can refer to this method. Okay, so this is the recursive. There are two methods actually. One is for the recursive method, one is for the recursive technique, this one, and this is the iterative method which is used in normal circumstances. So this one will be focusing only on the recursive technique. So let us see the program from the beginning. Let us check out the steps. So first of all, we have the function signature. So as I have told you in my previous sessions, so if we implement the body of a function below the main method, so in that case what we need to do is we have to give the signature of the function above the main method. Otherwise, if we call the function, then in some compilers, in certain C compilers, the function call may not work properly and the function may not be activated. So as you can see in this particular program, we have the main method, and below the main method we are providing the implementation of these functions. So here we have only specified the signature, and below the main method we are specifying the entire function including its body. So that is because of this reason we are specifying the method signature before the main method. So if the method signature hadn't been there, there was a possibility that when we called the function from inside main, it would not have worked. Okay, so it may or may not work, depends on the compiler. In this compiler that we are using, that is TDM-GCC, which is built into our dev-C IDE. So here we can surely use it. Even if we do not include the function signature at the beginning, it will work. Okay, but in certain compilers like the one that is built into Linux, for example, if we do not specify the function signature above the main method and we provide the implementation of the function that is being called from inside main below the main method, then it may not work. So to be on the safe side, I recommend putting the function signature above main. So this is how we are going to proceed. So first of all, we are inside the main method, and we are taking a number as input. Okay, and after that, obviously if the number is a negative one, if we enter a negative value, then we will simply output that the factorial, there is no factorial for a negative number, because obviously a negative number cannot be multiplied in that manner. And otherwise, if the function is a positive number, that is it has a value above 0, then we will say that the number of the factorial of the number is this. So here, instead of printing a variable, we are simply calling the function from this point onwards. So this is by using the factorial normal iterative method. So here you can see this fact num, this function call, this function call refers to this function, this particular function, and in this particular function that the factorial has been calculated using recursive technique. So this function call corresponds to the recursive technique, and if we do not wish to use the recursive technique, then we can also go for the regular method, but in this program our focus is on the recursive technique only. So if we wish to avoid the recursive technique entirely, we can go with this iFact function, where the function has been implemented by the regular technique. So we'll be studying both of them. So when we call this fact num function, the function call is transferred to this method. Okay, so here you can see that there is a method called longInt fact int n, and it says that if n equals to 0, then it is returning a value 1. Alright, otherwise if the value of n is above 0, then it returns n into factorial of n minus 1. So let us see how this actually works. So here is a screenshot from a book. So if we zoom into it, we can show you the details of how this function call actually takes place inside the compiler. So let me zoom out a little bit. So here you can see, I hope you can see this. So inside the main method, we are calling f equals fact3. So let us suppose that we are finding the factorial of 3. So when we find the factorial of 3, so this function fact is called, and this 3 is passed to this function as a parameter, and 3 is obviously an integer type value. So inside this function, if it says that if n equals 0, return 1, else return n multiplied by factorial of n minus 1. So when we try to obviously in the first step, it checks whether the value of n is 0 or not. It is not 0, it is 3 actually, which is above 0. So it goes to the second step, that is the second line. It is return n into a factorial of n minus 1. This is actually the third line, not the second one. So here what it does is, as of now it does not return any value. From this return statement, it is calling this same function but with factorial of n minus 1. Okay, so when this return statement executes, it does not return any value to the calling function, that is main method, right away. It calls the next function, which is factorial of n only with 2 instead of 3, because here we are calling n into factorial of n minus 1. So n minus 1 translates to 2. So inside 2, the same steps take place once again. It checks whether the value of n is equal to 1 or not. If it is equal to 0, it returns 1, else it returns n into factorial of n minus 1. So once again, this calls the next number in this series, which is 1. So as of now, the value of n is still above 0, so it returns n multiplied by factorial of n minus 1. So it goes to the final step where the value of n becomes 0. So here when the value of n becomes 0, this condition, this is quite like a loop. In fact, the loop is terminated when some predefined condition is satisfied. So this is this factorial, this recursive function call of factorial, this goes on as though it is bound to some kind of a loop, and the loop will go on forever unless there is a terminating condition. So if n equals 0, return 1, this supplies the terminating condition for this recursive calls. So when the value of n is equal to 0, this recursive function call will no longer take place. Okay, so this recursive function calls will cease. So this will return 1 to this function. So here what happens is that 1 is multiplied by 1. So now this value is returned to this function. So here it is returning 1 into 2. So here it is returning to the second function call, which is n into fact of n minus 1, and here the value of n was 3. So here it will multiply the output from this function, which is 2, with 3, and finally it will transfer this 3 multiplied by 2 multiplied by 1 to main method. So here we will get the value 3 into 2 into 1 equals to 6. So the factorial of this number will be 6. So this is what we have done here in this recursive function call. And in the iterative technique, as I've explained before, we are simply executing a loop that goes from 1 to the number itself, and in each step we multiply this value of fact with the counter, which is n. So there is nothing to explain over here. So let me just execute the function and show you the output. So let me take the value of 3 only. So this one is by the recursive function call, and this one is by the regular iterative method. Both the methods are outputting 6. So we are done with this program, and hopefully you have understood all the steps. If you still have doubts, please leave your queries in the comment section, and I'll see you all in my next video. Thank you and take care. Have a nice day.